Welcome. In this video, we'll see how to deal with statically indeterminate shafts that are made up of composite cross-sections. So we'll see an example here. This is an iPod cable. We kind of showed also a case of statically indeterminate but axially loaded members. So that was the axially loaded members under a tension, and we tried to solve for the tension in both the insulation and the copper wire inside. Now we're revisiting that, using that iPod cable, reviving it, and applying now a torque instead of an axial load from both ends. So kind of twisting it, that's a pure torque. And the question here is we need to find the how much of the torque that's applied on either end goes into or carried or resisted by the wire, and how much of it is the responsibility of the insulation. So how that does this T torque split between the wire and the insulation. So that's a statically indeterminate problem, and we'll see why. Because if we do the cross section here at somewhere between both ends of the cable, I will handle the right part of that cross section, so right free body diagram, and I have one of the torque loads, and then when I have the cross section I will reveal here the internal forces, including the split of the torque over the wire and the insulation. So I have a T wire, T insulation, and when I apply the sum of the torques or the sum of the moments around the x-axis, I will find here that I have one formula with two unknowns. I know that the torque load splits between wire and the insulation, but I don't know how much goes to the wire and how much goes to the insulation. That's a statically indeterminate problem. So how to solve for statically indeterminate problem? In strength of materials, we learned that deformations come to help us. So we know the compatibility of deformations here, that both copper and the insulation with the wire insulation twist and deform together the same magnitude of deformation, because we assume that there is good bonding between them, and the failure to be the section before it fails, they both need to be acting together as one section. So comparability of deformation here, in the case of torque, our main deformation that we can calculate and measure is phi, so the angle of twist. So we'll say that the angle of twist of the wire is equal to the angle of twist of the insulation along any length from T. Because it doesn't matter what's the length, because T here is consistent loading along the the two ends of the cable. So phi here, if I calculate it, the formula for it is TL over JG. Represent the values on both ends of the equation here. I know that the length will be the same, so I can cross both L values here. L wire is equal to L insulation. And now I will have a second equation to help me solve for the two unknowns and be able to solve this statically indeterminate problem. Thank you. I'll see you in other videos.